we're going to do 4.1. We're going backwards, because we're going to chapter 4. We're going to do 4.1. And 4.1 has to do with systems of equations. Notice plural, because a system would be more than one equation. And this is what it looks like. 2 equations, 2 variables. There is one answer that works in both of those equations. And they're going to give you, they start out pretty easy. They say, is this the solution? Is this the answer to that system? Meaning, if this is x and this is y, we plug it in. So for this one, we say x is 4 and y is 2. Does that equal 6? Yes, it does. But for it to work, it has to work in both. So if this x is 4 and y is 2, is 16 minus 2 14? Yes, it is. So the answer is yes, or true. That is the solution for this system. Now, that's the easy way. They give you the system, they give you the answer, and then they ask you, does it work or not? And remember, it has to work in both for it to be true. If it only worked in one, it would be false. Okay? But then they give you the system. So x plus y equals 5, and 2x minus y equals 4. And they say, you come up with the answer. Well, what do we know so far? If we were just looking at this, x plus y equals 5. To show the solutions for x plus y equals 5, remember that's a line. We'd have to move the x over, get it in y equals mx plus b form, and graph it, because anything that has 2 variables has multiple answers, has actually an infinite amount of answers, and the only way you can represent those answers is to graph the line that those answers fall on. So we're going to take this first, what we already know, and we're going to take this first, let me get a different color. I'll make this one pink. Okay, it was positive 5 was the y-intercept, and then the slope is negative 1 over 1. So you go down 1 and over 1. Excuse me for just a minute. Beth? Yeah, because I just started recording. She's 7 to 16. Oh, well, no, she could maybe a 6, and I get the 7. Then, well, if you got her medium in shirts, get her medium in that. Okay, I got to go because I'm recording. When I'm done. Bye. Okay. Sorry. So now we draw, and you can go down 1 and over 1 to try to help get the most accurate here. Okay, that's that line. Now let's do this line, this one over here. Again, we'd have to move the x over. You get negative y equals negative 2x plus 4, but you can't have that negative, so you divide by negative 1, and you get y equals 2 over 1x minus 4, which means negative 4 is the y-intercept. The slope is up 2 and over 1, up 2 and over 1, up 2 and over 1. So the slope, or this line, I should love my nice straight line, goes this way. Now, if this represents all the answers, okay, that line represents all the answers that work in this equation, and this Right here, this one represents all the answers in this equation. Then where they intersect would be the one answer that works in both, which in this case is x is 3, y is 2. So at 3, 2, we have the answer that works in both, and we can try. Does 3 plus 2 equal 5? Yes. Does 3 times 2 minus, does 2 times 3, x is 3, y is 2, minus 2 equal 4? Does 6 minus 2 equal 4? Yes, it does. So we found the one answer that works in both. If you graph to find the answer, you have to be extremely accurate. You have to be careful with your graph. You have to be careful counting and making sure. And what if, let's just say, because life isn't always perfect whole numbers, what if the answer to the problem, to the system, was x is 1/3 and y is negative 2/3? Are you going to be able to see that on a graph? Not really. So with what you know already, you could try to find the answer by graphing, but that's not the most accurate way. So we have another way. And another way is called the substitution method. Okay, so let's go back to that x plus y equals 5 and 2x minus y equals 4. In the substitution method, what we do is we try to substitute from one equation into another equation. And the way you do that is first you have to isolate a variable in one of equations. So I can isolate the x, I can isolate that y, I could isolate this x, or I could isolate that y. What would be the easiest to isolate? Well, if I tried to isolate that, it has a 2 in front of it, so I have to divide by 2 and I'd create fractions. Ew. If I tried to isolate this, I'd still have to get rid of the negative. 2 steps. These two, to me, seem to be the easiest to isolate. If I have x plus y equals 5, all I need to do is move the y over, and I get x equals 5 minus y. I've isolated x. Now, once you've done that, substitute into other equation. Meaning, if x is now 5 minus y, then in this equation, wherever there's an x, I'm going to write 5 minus y. I substituted this into the other equation. Now I can solve because I only have one variable. 2 times 5 is 10. 2 times negative y is negative 2y minus another y equals 4. 10 minus 3y equals 4. Combine like terms. Move the 10 over. I get negative 3y equals negative 6. Divide by negative 3, and I get y is 2. Okay, so, and solve. Then go back and solve for other variable. Meaning, if I know y is 2, plug it in there, x equals 5 minus y, which is 2, so x is 3. So my answer is 3, 2, which is what we'd already figured out when we graphed it, but I just wanted to show it to you another way. Okay? All right, let's try another one. Let's try another one so you can see this whole process. Okay? Go back to black. Okay, what if I had, here's my system, 3x plus 2y equals 13, and 4x minus y equals negative 1. All right. What would be, if we're going to solve this through substitution, what would be the easiest variable to isolate? If I isolated this, I'd have to divide by 3 and I'd create fractions. If I isolated this one, the y, I have to divide by 2 and I'd create fractions. If I isolated this x, I divide by 4 and create fractions. So this one is our best bet. We take 4x minus y equals -1, and I isolate it by moving this over. I get -y equals -4x, oops, -1. It doesn't matter if I write it -4x minus 1 or -1 minus 4x, doesn't matter. But I do have to get rid of this negative. So I get y equals positive 4x plus 1. Now, I used this one to isolate, so I use this one to substitute. So 3x plus 2, and instead of y, we're going to put what y is now, and y is now 4x plus 1. So now I only have one variable. Distribute. I get 8x plus 2 equals 13. Combine 11x plus 2 equals 13. Move the 2 over. 11x equals 11. So x equals 1. Got the first one. Now I put it back in here. Y equals 4 times whatever x is, which in this case is 1. So y is 4 plus 1, so y is 5. So my final answer is this. Okay? All right? That's substitution. Now, there's another method called elimination. Elimination looks at a system and adds them together down the rows. Adds the x's together, adds the y's together, and adds the numbers, or what we call constants, together. But by doing so, you want to eliminate one of the variables. So look at this. If I add this, I get 6x. What happens if I add this? What's positive 3y and negative 3y? They're gone. And what's negative 6 and positive 6? 0. Divide by 6, and you have x is 0. This won't always happen. Those won't always eliminate, okay? But in this case, it just happened that it came out to be 0, okay? Now, if that's the case, I already know I've solved for one of my variables. I can go into either one and solve for the other. So I'm just going to take this first one, and instead of x, I put 0, which means I get 3y equals -6, so I get y is -2. So my answer is there. Now, that was easy because they had it set up already for you, something eliminated. But what happens if it's not set up like that? Well, let's look at another one. What if I had 5x minus 2y equals 4 and 2x plus 3y equals 13? Does anything eliminate? 5x and 2x give me 10x. Negative 2y and positive 3y give me 1y. So it doesn't eliminate all by itself. But I can do something. I can do something to each equation, as long as I do it to the whole thing, to create new equations where something eliminates. Now, I could do the x's or I could do the y's. It's completely up to you. I'm going to choose to eliminate the y's because I already have a positive and a negative. I have a negative 2y and I have a positive 3y. So I already have the negative and positive. Now I have to consider this 2 and this 3. What could I multiply them by to create a number that would be the same. Well, does it make sense for me to say that 6 is a number? I can multiply 2 by something to get 6, and I can multiply 3 by something to get 6. Meaning, if I multiply this whole thing by 3, and I multiply this whole thing by 2, look what happens. What do I get? I get 15x minus 6y equals 12. Here I get 4x plus 6y equals 26. These cancel out. This gives me 19x, and this gives me 38. Divide by 19, you get x is 2. Done. I have one variable. Now, I can go back into either one, so I'll just take this second one this time. It doesn't matter. And instead of x, I'm going to put a 2 so that I can solve for y, because x is 2. So 4 plus 3y equals negative 13. Move the 4 over. You get 3y equals negative 17. This is not coming out right. I must have wrote the problem down wrong. All right. Well, lucky us, y is negative 17 thirds. Okay. So my answer is negative 2, negative 17 thirds. Okay. 15. Well, I'm just making sure. 4, 6, 26. That's 38. 2 times 2 is 4, plus 3, right? Oh, I see what was wrong. It was a positive 13, not a negative 13. It's a positive 13. So what do you get? You get 3x equals 9. So x is 3. I'm sorry, y is 3. Okay. My mistake. See how easy, how quickly that can happen? Whew. All right. Well, there's 2 other things that could happen. I want you to see this. What if I had 2x minus y equals 3 and 6x minus 3y equals 9? And we can solve, I'm going to tell you, we can solve this through graphing, through substitution, or through elimination. Doesn't matter. Okay? I'm going to go ahead and do elimination because this is a 6 and this is a 2. Can you see that if I multiply this by negative 3, what will that give me? Will my x's cancel out? I get negative 6x, positive 3y, and negative 9. And this one I don't change. Positive 6x minus 3y equals 9. Do my 6x's cancel out? What am I left with? Ew. I'm left with 0 on one side and 0 on the other. Does 0 equal 0? Yeah, it does. When this happens, when everything cancels out, then your answer is all real numbers, because it doesn't matter what you put in there, it'll work. What that means is that these 2 things are the same line. They're one on top of each other. So all real numbers will work. Okay? Or this could happen. What if I had x plus 3y equals 4 and negative 2x minus 6y equals 3? Again, I'm going to use elimination because I'm going to show you that if I multiply this by 2, I'll have a 2x and a negative 2x. So those will cancel out. So what do I get here? I get 2x plus 6y equals 8. I multiplied the 2 by each. This one I didn't change. Negative 2x, negative 6y equals 3. My x's cancel out, but what happens to my y's? They also cancel out. So I have nothing on this side, but what do I have on this side? 11. Does 0 ever equal 11? No. So here your answer is no solution. what you need to realize is that these two equations are parallel lines. If you thought about them on a graph, they're never going to intersect, so they're never going to have a solution. So when it comes out with everything's gone, it's all real numbers. When it comes out with something that doesn't make sense, it's no solution. Okay? And that is 4.1.